Welcome to this video session. My name is Samuel Chukwuemeka. As usual. In this video session, we shall discuss overview of linear systems. At the end of this video, students are expected to learn the concept of linear systems and also classify linear systems. Why are we studying linear systems? Linear systems are used in the business field to determine profits or losses from business transactions. They are also used in the manufacturing industries for production and work scheduling. We use this system to make schedules, to make placements. Also, when we want to place doctors for internships, or when we want to create schedules for nurses, for workers, we make use of this system. It's also used in several sectors to solve problems. So this is an important concept in mathematics that is used in many sectors. Let's look at the overviews of linear systems. What is a linear system? A linear system is a system of linear equations. You can also say it is a set of linear equations. So if you have two variables in two equations, that gives you a 2 by 2 linear system. We pronounce it as 2 by 2. Two variables in two equations make a 2 by 2 linear system. If we have three variables in three equations, it will make a 3 by 3 linear system. If we have four variables in four equations, it will make a 4 by 4 linear system. If we have five variables in five equations, we have 5 by 5 linear system, and so on, 6 by 6, 7 by 7, and so on. Now, we do also have a situation whereby the variables are more than the equations, or the equations are more than the variables. Those are when we have over-determined and under-determined systems. But we shall not discuss it in this video. We are going to talk about it in another video. So for this case, we are just looking at like a square matrix, 2 by 2, 3 by 3, 4 by 4. For this course, we are only interested with 2 by 2 and 3 by 3 linear systems. Usually, we classify linear systems as being consistent or inconsistent. When we talk about consistent systems, we mean any system that has at least one solution. At least one means greater than or equal to 1. At least one means greater than or equal to 1. It could be 2, it could be 3, it could be 4, but it has at least one solution. We say that such system is a consistent system. We can also classify a linear system as inconsistent. An inconsistent system is a system that does not have a solution. We can further classify consistent systems as independent. If we have a consistent and independent, that means the equations in the linear system have different graphs. Remember, a linear system is kind of like a set of linear equations. So it's more than one. We talk of linear system as a system that has more than one equation. At least it's more than one. It starts from 2. So when we, assuming we are looking at a 2 by 2 linear system, that means each equation has its graph. Equation 1 will have its graph, and equation 2 will have its graph. So when we have such case, we say that the system is independent. The consistent system is independent. So we say consistent and independent system. We can also have consistent and dependent systems. If the equations in the linear system has only one graph, that means all the equations have only one graph. We say that that system is dependent. And as we will look at, as we'll get to see later on in this video, you will see that the graphs are superimposed on one another. So that creates that image that it's only one graph. And these are consistent systems. Can be classified either as independent or dependent. So we have 3 types of systems. We have consistent and independent system. We have consistent and dependent system. And we have inconsistent system. Now, remember, for the first 2, consistent and independent, and also consistent and dependent, they have at least one solution. For inconsistent, there is no solution. Now let us compare and contrast these systems. We have 4 main properties that we shall look at. The first property is nature of solutions. What is the nature of solutions of these systems? When we look at consistent and independent system, it has a unique solution. It has only one unique solution. Inconsistent systems do not have a solution. Then consistent and dependent systems have many solutions. When we talk of the nature of the graph, as we will get to see later on in this video, with consistent and independent, the graphs intersect at one point. When they intersect at one point and the coordinates of that point gives you the solution. The coordinates of that point of intersection gives you the solution. For inconsistent systems, the graphs are parallel lines. As you can recall from the definition of parallelism, parallel lines, they are lines that do not meet. No matter how you extend them, no matter how you stretch them, the lines will not meet. So, because they do not intersect, no matter how they are extended, they are parallel and they do not have any solution. For consistent and dependent, the graphs are kind of superimposed on themselves and making it just a single line. When we talk of the slope, what is the nature of the slope? Consistent and independent systems have different slopes. The 2 graphs will have different slopes. Inconsistent systems, the graphs have the same slope because they are parallel lines, so they have the same slope. Parallel lines have the same slope. Then consistent and dependent systems also have the same slope because it's just a single line. When we talk of the nature of their y-intercept, for consistent and independent systems, they may or may not have the same y-intercepts. They may or may not have the same y-intercepts, but inconsistent systems will have different y-intercepts. Of course, they do not touch, so they will have different y-intercepts. And the consistent and dependent systems will have the same y-intercepts. So this is the comparison, compare and contrast of these systems. Comparing these systems in reference to the properties. Now, how can we determine what type of system we have? So, let's say we are given some systems, some linear systems, and we are asked to find out whether they are consistent and independent, or inconsistent, or consistent and dependent. Please, most textbooks, when they, most textbooks you will see when they talk of consistent, they mean consistent and independent. When they talk of inconsistent, they still mean inconsistent. And when they talk of dependent, they mean consistent and dependent. So, for this course, when we say consistent, just know that we mean consistent and independent. When we say inconsistent, we mean inconsistent. When we say dependent, we mean consistent and dependent. That is what you will see in some textbooks, just consistent, inconsistent, and dependent. So, if we are given a linear system and we are asked to determine whether they are consistent or inconsistent or dependent, how could we do that? First of all, we could check for relationships between the same variables. If we are doing this, we have to line up the variables, make sure that the variables match in each equation, and then we check for relationships between them. We shall look at that. We could also graph each equation. When we graph them, if we graph them, we could find out the nature of the graph. If the graphs intersect, that means they are consistent. If the graphs are parallel lines, that means they are inconsistent. If the graphs are a single line, that means they are dependent. So that's the second one. We could graph it. The third one, we could write each equation in slope-intercept form. Do you still remember slope-intercept form? I hope you still remember it. Y equal to mx plus b. You may need to view the video I did on graphs, slopes, intercepts, and linear functions. So this is the slope-intercept form of a straight line. M is the slope and b is the y-intercept. Your mama ex-boyfriend. Okay, so you could also use this to find out the type of system you have. How could you do that? When you have to put each equation in this form. If you put this equation in this form, then you find out the nature of the slope. M is the slope, and b is the y-intercept. You find out the nature of the slope and the nature of the y-intercept, and then you compare it with this. Find the nature of the slope and find the nature of the y-intercept, and then you can find what kind of system it is from here. Another thing you could do is to write an augmented matrix. You could write the linear system as an augmented matrix, and you now reduce it. You apply row reduction operations. You reduce it to a row echelon or row echelon matrix. We shall talk about that when we do matrices and determinants. But that is another way you could find out what kind of system you have. Now, for this video, we shall just do the first two. That is what we shall do, the first two. This second one, we're not going to graph it because of time. I have done a video whereby we did graphs. But you can, I will use a graphing calculator from my website to show you that. Yeah, but let's go ahead and do this first one. then we shall do the second one. We shall do these two methods in this video, and another video we shall check using the slope intercept form, and another video we shall check using the writing it as augmented matrix and using row reduction. So let's look at the examples we have here. Determine whether the system is consistent. Remember, this consistent means consistent and independent. Inconsistent or dependent. Remember, this dependent means consistent and dependent. And how and why. Alright, now let's look at question 1. Remember, I said here, check for relationships between the same variables and line up the variables and check. You need to line it up. If it is not lined up, what do I mean by that? For question 1, it is lined up. You have x, x, y, y, right? So it's lined up already, so that's good. Now let us check for relationships between the variables. You start with x. This is equation 1, this is equation 2. In equation 1, what will you do to 2 to give you 4? Is there any relationship between 2 and 4? You say yes. 2 times 2 is 4. Now, please, when we are checking for relationship, we are not using addition and subtraction. No, we are going to check it using multiplication and division. If I ask you, what will you do to 2 to give you 4? I don't want you to tell me add 2, 2 plus 2, 4. I don't mean that. What I mean is can you apply any multiplication or division operation to give you 4? That is what I mean. If I ask, what will you do to 2 to give you 4? It means, is there anything you could multiply or divide by 2 to give you 4? I am not asking for addition or subtraction operations. So when you have 2 to 4, it means if you multiply by 2. So 2 times 2 will give 4. 2 times 2 is 4. Then that is for x. Then you come here, this is a negative 5, and this is plus 3. If you do negative 5 times 2, if you come and do negative 5 times 2, right? It gives you negative 10. So there is no relationship, between the variables. Here you multiply by 2, but if you come here and multiply by 2 again, you won't have a positive 3. And if you look at the constant also, if you look at the constant as well, I think that's check for relationships between the same variables and constant. You can add and constant here. So if you look at the constant, it's still not any relationship here. You see that? 1 times 2 is 1 times 2 will give you 2, not 15. So because of this, because we can 1 times 2 will give you 2, not 15. So 1 times 2 will be 2, not 15. Let me erase this eraser. Pointer, pen. So 1 times 2 will give you 2, not 15. So because there is no relationship, we say that this is a consistent system. Therefore, it has one solution. We shall still, everything we do here, we shall still use graph to check it. We shall use a graphing calculator on my website to check it. Okay, let's look at question 2. Here, the coefficient of x is 15. Here, the coefficient of x is 3. Right? So, what will you do to 15 to give you 3? You divide by what? You divide by 5. You divide by 5 to give 3. All right. Then you come here again. Here the coefficient is negative 20. Here is negative 4. So you notice that when you come and divide a negative 20 divided by 5, again, it will give you negative 4. So there is a relationship here. Okay, there is a relationship here. Now, if when you are doing this, then you now say, okay, since this worked on the left-hand side, remember we are dealing with equations. And with the equation, whatever you do to the left-hand side, you've got to do to the right-hand side. Already in equation 1, on the left-hand side, we have divided it by 5 to get equation 2, the left-hand side. So that tells you that if you come and divide 21 by 5, that tells you that if you divide 21 again by 5, that you are supposed to get 7. But 21 divided by 5 does not give us 7. It doesn't give us 7. Okay? So, what does it tell you now? That you're inconsistent. You come and do something on the left, and you don't want to do it on the right, for this is an equation. You're inconsistent. You say something yesterday, and you come today and you say a different thing. You're inconsistent. Because if you had to divide the left-hand side by 5, right? You divided the left-hand side by 5 to get, for the equation 1, to get the left-hand side of equation 2. Then if you're consistent, you should have also divided the right-hand side by 5 so that you can get the right-hand side of equation 2. But because you got a different thing, that means you're inconsistent. You know, here when you come and say that 2 plus 3, let's bring this to arithmetic. If you say that 2 plus 3 is 5, and then you turn around again and say that 2 plus 3 is 7, that means you're inconsistent. If you come and say that 2 plus 3 is 5, and then of course, if you multiply this by 2, it gives you 4, plus you multiply 3 by 2, it gives you 6. You now come and say that 4 plus 6. Now you're supposed to multiply 5 by 2 to get 10. But you come and say that this is 12. That means you're inconsistent. You say that you support that you believed in global warming yesterday, and tomorrow you say you don't believe in global warming. You know, you say you said yesterday that you believe in global warming, so that you can get votes. People can vote for you. Then today you say you don't believe in global warming because you see that the demographics that will vote for you have changed. And those demographics don't believe in global warming. Therefore, you now change your views so that you can get more votes. You are what? Inconsistent. So you see that our politicians, a lot of our politicians are inconsistent because they are inconsistent to get votes. They change their opinions so that they can get votes. That is a good example of this. Inconsistent. And therefore, no solution is not going to work. That is no solution. Now, number 3, you look for the relationship. Here, the coefficient is 2. Here, the coefficient is 6. So you see that 2 times 3 is 6. Right? 2 times 3 is 6. Then you come here, negative 5 and negative 15. You also see that negative 5 times 3 will give you negative 15. Then, of course, you now applied it to 10, and you see again that 10 times 3 is 30. So you're just saying the same thing, right? You're saying the same thing because what you did to the left hand side is still what you did to the right hand side. So you're saying the same thing. So these two equations mean the same. If we want to write again, if we want to write 2 times 4 is what? 8. 8x. Minus 5 times 4 is minus 20. Minus 20y equal to 10 times 4 is what? 40. You are saying the same thing. You are simply saying all this, if you come and divide this equation 3 by 4, you get equation 1. If you divide equation 2 by 3, you get equation 1. Okay? So you're saying the same thing, and because you're saying the same thing, the solution is dependent. So it has many solutions. It is a dependent system. The system is dependent, and it has infinitely many solutions. So that is the way you do it. Make sure that it is lined up. Make sure that the variables are lined up. Then you check for relationships. And when you check for relationships, if there's no relationship, then it is most likely it will be consistent. If there is a relationship, you now find out what kind of relationship. If you say something yesterday and you turn around and say a different thing today, okay, then it's inconsistent. You're inconsistent. You're not consistent with what you said. Then if you're still saying the same thing, some folks end up saying the same thing anyway, then that means it's dependent system. All right. Now in this one, question 4, you see that this is not lined up. So we do what? We have to line it up. And if we line it up, this will be 0.3x. If we bring this over here, right? If we bring this over here, this is minus 0.3x plus y equal to 0. And then this will still be 0.07. This will still be 0.07x plus 0.12y equal to 3.18. If we look at this, if you don't like decimals, let's say you don't like decimals, right? So what you could do is just convert it to whole numbers, to integers, because convert it to integers, because with the equation, whatever you do to the left hand side, you can also do to the right hand side, and it still gives you the same thing. So if you want to convert this, this will be what? Minus 3x. We multiply both sides by 10. We multiply this equation by 10. Minus 3x plus 10y equal to 0. And in this case, we could multiply the equation both sides by 100. And this will be 7x, provided that what you do to the left hand side, you should do to the right hand side. Then that is still correct. 7x plus 12y equal to 318. So these and these are the same thing. They are. This and this are the same thing. If you don't want to use a calculator, these and these are the same thing. So provided that whatever you do to the left hand side, you have to do to the right hand side. Now we can check for relationships. What will you do to negative 3 to give you 7? That means what? How will you do this? Negative 3 times p to be 7. What will you multiply by negative 3 to give you 7? So p will be 7 over negative 3. So p will be negative 7 over 3. we don't put the negative in the denominator. We bring it to the numerator. So if you multiply negative 3 by negative 7 over 3, you will get 7. If you multiply negative 3 times negative 7 over 3. Negative times negative is positive, and then 3 divide 3. So you have, which is 1. 1 times 7 is 7. Now, if you do the same here, 10 times negative 7 over 3, is it going to give you 12? 10 will not even cross out. I mean, 3 will not even cross out 10. So, because 10 is not a multiple of 3. So, you see, there's no relationship. And because there's no relationship, what is it? Because there is no relationship, it is a consistent system. And it has one solution. Next one, question 5. If we look at this, we have to arrange it. So let's go ahead and arrange it. If we arrange it, if we bring this over here, we have that 3 over 2, 3x over 2 plus y is equal to 3. That is what we'll have. So if you don't like fractions, let's say you don't like fractions, right? So what's the LCD? You can view my videos on fractional equations, part 1 and part 2. So if you don't like fractions, you multiply this by 2, multiply everybody by 2, so that you can clear away the fractions. Now you know that this x belongs to 3, not 2, because some folks will think that is 2. So if you don't like fractions, you can go ahead, multiply by the LCD. 2 times y equal to 2 times 3. So this equation right now, as you see it, this equation right now, because 2 cancel 2 is that. So this equation is now 3x here, 3x plus 2y equal to 2 times 3 is 6. So you now check for the relationship. You must make sure that you line it up, line the variables up. Okay, x, y, y, then the constant. So 3, what will you do to 3 to give you 3? You multiply by 1. Now, what will you do to 2 to give you negative 4? 2 times 1 will not give you negative 4. So there is no relationship. So it is what? Consistent. One solution. If there is no relationship, it will be consistent. Question 6. Let's line this up. If we line this up, right, if we bring this over here, that will give us minus 10x plus 15y equal to minus 7. Okay, I can look at this right now and say that you're being inconsistent. I mean the system, not you. Not you, but the system. I can look at this right now and say that this system is inconsistent. Why? Okay, you've got negative 7 here and you've got negative 7 here. But 4x and minus 10x is not the same thing. Minus 6y and 15y is not the same thing. Okay, like I said, you know, in the previous one, like I said, remember what we said in the previous. You come and say 2 plus 3 is 5. And you come again and say 2 plus 3 is 7. Or you say 2 plus 3 is 5. And then you say 4 plus 6. Instead of it to give you 10. So that you can make it a dependent system. You now say 4 plus 6, 12. Is inconsistent. Yeah. So, and you can come and say maybe you have to be for it to be that, it has to be, for it to be dependent, then both of them will be equal. So if you look at this now, this is negative 7, negative 7. So if you look at this now, right? Even if you check for the relationships, you will see that you did something here. You will do something to negative 10 to give you 4. But you see, this is negative 7, negative 7. It makes it inconsistent right away. There's no solution. Because whatever thing you did here, and probably you did here, since this will not change, this is still negative 7, negative 7. It makes it inconsistent. So you don't even have to waste time looking for the relationship. If you see that both of them are the same, while this other one are different, then if you see that they both gave the same result, even though the left hand side are different, just know that they are inconsistent. Now this one, let us line it up. This will be 3x plus y equal to 5. Let's line it up x first, then y on the left hand side. Then if this comes here, this is 6x plus 2y equal to this goes here 10. Did you see what I did? Now you know you can swap. You can also swap, but this will be minus 6x minus 2y equal to minus 10. And then you divide both sides by minus 1. You will still get this. It's still the same thing. So look at this, 3 and 6. You multiply by 2, right? 3 times 2 is 6. Here is like 1. If you have just y, it means 1y. That's what it means. So 1 times 2 is still 2. You have that 3 times 2 is 6. And you have that 1 times 2 is 2. And you have that 5 times 2 is 10. So you are saying the same thing. Folks, you are saying the same thing. So that is dependent, infinitely many solutions. Question 8. We are coming there. Now we have these fractions, and some people get scared of fractions. If you have fractions and you don't like fractions, what should you do? Find the LCD and multiply by the LCD so that you can have only integers. So what's the LCD of 344? That is 12. So this is 12 times 2x over 3. 2x over 3. Then plus 12 times 12 times, let me erase this, 12 times 1y over 4. 1y over 4, if you want to put 1, that's fine. I'll just put y over 4 equal to 12 times negative 1 over 4. So 3 will divide 3, 1. 3 divide 12 is 4. 4 times 2x is 8x. So this is 8x. Plus 4 divide 4, 1. 4 divide 12 is 3. 3 times y is 3y. Equal to 4 divide 4, 1. 4 divide 12, 3. 3 times 1 is negative 3. Then for this one, LCD is 60, right? 2 into 60 is 30. 30 times 1x is 30x. 30x minus 5 into 60 is 12. 12 times 2 is 24y. I'm doing it now, mental work. Equal to, of course, 60 divided 60 is 1. 1 times negative 23, negative 23. All right, folks, does this have a relationship? Looking at it, 3 times negative 8 will give you negative 24. Is that right? If we start with y, 3 times negative 8 is going to give you what? Negative 24. But now, if you do negative 3 times 8, it won't give you negative, If you do negative 3 times negative 8, it won't give you negative 23. And then if you do 8 times negative 8, 8 times negative 8 will not give you, it's not equal to 30. 8 times negative 8 is negative 64. It's not going to give you 30. So because of that, this is consistent. Then if you come here, LCD is 2. 2 divided 2 is 1. So this is negative. Well, bring this guy over here. This is x. X minus 1 over 2. Y over 2. Let me just put it y over 2 equal to negative 4. Yeah, bring this guy over here. X minus y over 2 equal to minus 4. Then here will be 8. If we switch this, because I don't want to deal with negatives, or even, it doesn't matter, I can deal with negatives. Negative 8x plus 4y and bring this guy over here equal to 1. Okay, if we look at this now, if you don't like fractions, LCD here is 2. So 2 times x is 2x. So you have 2x minus y, because 2 divided by 2 is 1. 1 times y is y, equal to 2 times negative 4 is negative 8. And then here is still negative 8x. So you see, you line it up. Negative 8x plus 4y equal to 1. Okay, what will you do to 2 to give you negative 8? You multiply by negative 4. 2 times negative 4 is negative 8. Now, if you do negative 1, because this is negative 1y, this means 1. So if you do negative 1 times negative 4, you will still get 4. So there's a relationship, you see. You still get 4. Then if you do negative 8, negative 8 times negative 4. Because whatever you do to the left, you are supposed to do it to the right. Where negative 8 times negative 4 is not equal to 1. So there's a problem. You're being inconsistent. Okay, if we had 32, that means it's dependent. That means you're saying the same thing. But negative 8 times negative 4 is not equal to 1. So you do something on the left and you don't do it on the right. You are inconsistent. So there's no solution. Then question 10. This, if we multiply by 2, 2 is the LCD. We will have a negative 3x plus 6y equal to negative 2. That's equation 1. Here, if we bring this guy over here and move this guy, or what we can do, we can switch. Okay, we can actually switch. This is like saying, see what I mean by swap. 3x is what? 2 plus 6y. You could do that also if you view my videos on equations. So this will now be 3x minus 6y equal to 2, because this is the only guy you bring here on the left hand side. Alright, let's look for relationships. What will you do to negative 3 to give you 3? You multiply by negative 1. Negative 3 times negative 1 is 3. Okay. What will you do to 6 to give you negative 6? You multiply by negative 1 to give you negative 6. Okay. And what will you do to negative 2 to give you 2? When you multiply by negative 1 again, you have 2. So you are saying the same thing, though. You're saying the same thing. And because you're saying the same thing, it is dependent. Infinitely many solutions. So that is the that is checking for relationships. Now, the second way is to check it by graph. And in graph, let's see, if we check it in graph, okay, these are the references. Now, the second thing we can do is to check by graph, because that is what we said. And this is what we can do. Just go to my website. When you click on my website, click on my picture to enter the site. Click on mathematics. There is a graph I like using. There's a graph I really like using, and it's in algebra resources. That's the Desmos graphing calculator. Cool. I like this graph. Now you could graph this with your TI-84, at least from TI-83, TI-84. If you have a TI-84, okay, or TI-84 plus, you could start from here. You click here. Let me open this in new tab, and this is the calculator. Go to graphing, and just, this is your TI-84, and walk through this. Walk through it. This is a graphing calculator tutorial. It's right here, TI-84. Okay, now you could do this with your TI-83, TI-84, TI-Nspire. Okay, but for this video, so that it wouldn't be long, we'll just use this. Now, I like this graph a lot. It has a lot of things, a lot of stuff. If you have, it can do a lot of functions. So that's why I like it. They didn't pay me to campaign on this. They didn't pay me to advertise on them, but I've been using it, and it's, for this video to be short, I want to use it to kind of show you how you can identify the system just by graphing it. So we will go through the 10 questions. Number 1 is 2x minus 5y equal to 1. And then number 2 is 4x plus 3y equal to 15. So you see it is consistent. Okay, and the solution is 3 and 1, you see. So this was the first equation we did. It is consistent. The next one, 2. You have a 15x minus 20y. So if it's consistent, it will intersect. But if it's not consistent, let's see. 15x minus 20y equal to 21. And the next one is 3x minus 4y equal to 7. All right, so you see this now, inconsistent. The graphs are parallel lines. You see that? The graphs are parallel lines. They will never meet. So this is inconsistent. The next one, we have 2x minus 5y equal to 10. And then 6x minus 15y equal to 30. So you see, look at this color. You see this color? You can even change the color. If you click on this, you remove the color, you click on it, you put the color. You see they are superimposed. They are superimposed on themselves. Can we generate another one? 2 times 4 is 8x minus 5 times 4, 20y equal to 40. 8x minus 20y equal to 40. You see, they are superimposed on themselves. See what I'm talking about? You see that? All these are what? Dependent. You can also have 2 times 5 is what? 10. 10x minus 5 times 5, 25y equal to 50. You see, they are superimposed on themselves. Is the graphs are just one line. The graphs are just one line. Let's even, it works with negatives too. Negative 6 times 2 is negative 12x. Plus negative 5 times negative 6 times 2 is negative 12x. Negative 6 times negative 5 is plus 30y, equal to negative 6 times 10 is negative 60. See that? So you're just saying the same thing. You are just saying the same thing. Okay, they are superimposed on them. So you can try this for all of them. Even for the fractions, it does not matter. Let's look at one fraction that is inconsistent. Number 9, negative 1 over 2. If you're writing fraction, just write it, but make sure that if you're writing fraction, make sure you don't do it like this, because if you put your y here, then that's wrong. Okay, make sure you kind of do your cursor, the right cursor key, then y, negative 1 over 2y, equal to negative 4 minus x. That's the first one. The next one, negative 1, equal to negative 4y plus 8x. You see that it is inconsistent. Even if you pull it like this, you see it's inconsistent. If you enlarge the scale, I mean, if you enlarge the scale, you still see it's inconsistent. All right, so we're gonna stop here for tonight. So we're gonna stop here, and if you have any questions, please feel free to ask. Thank you for listening. You have